At this point, we'll move on to some other examples, but first I wanted to explain one of the most important concepts in the topic of sampling distributions. This concept is called the central limit theorem. The central limit theorem allows us to predict the shape of a sampling distribution of sample means without having to create the sampling distribution. In other words, the central limit theorem allows us to predict the shape of a sampling distribution without having to actually calculate the mean of every possible sample that could be selected from the population. According to the central limit theorem, the shape of a sampling distribution of sample means is predictable based on the shape of the population and the sample size. The central limit theorem makes a couple of important points. First, it says that if the population is normal, then the sampling distribution is always normal. In other words, if the individuals in the population follow a normal distribution, and you randomly select a sample from that population, and you calculate the mean of your sample, the means of all of the possible samples that could be selected will follow a normal distribution, regardless of what sample size you're using. The other point that the central limit theorem makes is that if the population is skewed, then the sampling distribution is skewed, just like the population when a small sample size is used, but is roughly normal when a large sample size is used. In this case, large generally means 30 or larger. In other words, if the individuals in a population have a skewed shape, and you randomly select a small sample from that population, and you calculate the mean of your sample, the possible samples that you're drawing from will have sample means that follow a skewed shape that looks just like the population. However, if a population is skewed and you randomly select a large sample from that population and you calculate the mean of your sample, then the possible samples that you're drawing from will have sample means that follow a roughly normal distribution, even though the population that the sample is coming from is skewed. And this concept is difficult to understand at first because it seems really abstract, but I'll show you a simulation website that I think will make this idea more clear.